Hey everyone, welcome to this video where I'll be talking about my project which I recently completed. My name is Shahir. Nice to meet you all. This project is a batch data pipeline, which the data source here is Google Ads. I've used a different variety of technologies from Airbyte, DBT, Postgres. All right, to walk through about the structure of the project in this presentation today, or rather this video. Um, we'll first talk about the architecture, then go to the statement, which is the problem we're trying to solve. Next, we'll talk about each of the different components of the pipeline. Let's talking about data source, which is Google Ads in this case, data ingestion tool I use, which is Airbyte, then talking about data transformations, which is TBT, and talking about data storage, which in this case I use Postgres, then the visualization tool, which is Looker Studio, and then the last section would be about future iterations I would like to add to this project to make it even better. All right, starting off with the architecture. The architecture is pretty simple. Started off with data source obviously being Google Ads, as shown here. Ubuntu EC2 is used on AWS. Ubuntu is the OS. Then to talk about, we use data for data ingestion, we use Airbyte, and then for data transformations, use DBT. For data storage, use Postgres, and the visualization tool was Data Studio. All right, to talk a bit more in detail about the architecture. Firstly, EC2 was used as mentioned earlier. Docker Compose was used to set up and run Postgres and Airbyte containers. Then next, to run the DBT models, a shell script was used with cron tab. A preview of both are shown below. Uh, the DBT models were to be are scheduled to run at 6:30 p.m. Eastern. And the next slide, I'll talk about more of the output from the contract script. Here, as you can see on the right side, I have the output for all the DBT models which were run. The script sort of tells me about the start time, the end time, any errors the models ran into, when was the model finished. So yeah, this file is produced pretty much on an every run basis. All right, moving on to the next section, which is the problem statement. Here, we'll talk about why was this project created to begin with. What is the problem we're solving here? All right, to dive deeper into this is this project sort of encompasses the modern data infrastructure where data stack rather where I've used the whole goal was to sort of reduce the net manual data pulls being sort of carried out by the analysts on the team. Instead of them sort of exporting Google Ads on a weekly basis, it was best sort of to make a pipeline which would be automating that task and sort of providing them with a reporting view on Looker Studio. Main reports they were pulling out were for campaigns and keyword analysis, which I'll talk more in detail about later. This is again sort of reiterating the different parts I broke this project into. Part A is data structure, which I will talk about. Next part is data extraction and processing. To talk about what tools were used, which version of the tools were used for Airbyte and Google Ads API was used here. Airbyte version 3.7.1 was used. DBT was used to sort of create the staging, intermediate, and MART models for transformation of the raw data. And then in this part, there were two big tables, which was the final output, which is first the ad view, and second is the keyword view, both of which are found in the Google Ads UI, which I'll talk a lot more in detail in the next sections. And part C of this project was data storage and analysis and visualization. The output is the DBT models, which are stored in Postgres, which I'll sort of walk you through in more details of which ones were views, which ones were tables. All right, moving on to the third section. In these subsequent sections, I'll go in more details for each of the tech stack I've used. So starting with the data source being Google Ads, the main task, rather the main views we were expected to sort of for this project to be the output for were the ad view. This view is mainly comprised of sort of these dimensions, which is called ad name, campaign name, ad group, and status. alongside other key metrics such as cost, clicks, and many more. More details are shown in the next slide. Next view, we are exporting as the final output of this project is a keyword view. This view is mainly comprised of these dimensions. There's keywords, there's match type, there's campaign name, ad group, and status, alongside key metrics such as cost, clicks, impressions, interactions, and so on and so forth. This view is also shown in the coming slides, which I'll talk more about. The next step is sort of the next steps which I'll be talking about is sort of to evaluate which tables from the API would be required to create these two views, which I mentioned above. All right, moving on to the next section. As mentioned earlier, this is sort of the view or the end goal of this pipeline. This view is shown in the Google Ads UI or the website. The This pipeline is sort of to mimic and produce the same outputs, but in an automated visualization tool such as Looker Studio. So this is the ad view. As you can see, there's ad names, campaign names, ad group, and the other metrics. And then there's the keyword view. Here we have the keyword, match type, campaign, ad group, as I talked about this earlier. And then the metrics are cost, clicks, and impression. This is taken straight from the Google Ads UI, just to show you the final what the end goal is. All right. Moving on to the next section to talk more about Airbyte, the data ingestion tool in this project. The following tasks were sort of carried out. We had to set up the connectors for source and destination in Airbyte. Source connector was Google Ads, as you can see here. I've put screenshots just for context and for more details. For destination, obviously we use Postgres, as I mentioned earlier, and then the last screenshot at the bottom is about the connections which I made, which can be shown below. Just a quick note, due to an error in Airbyte's version, which I was using earlier, I had to create two separate connections, as you can see in the screenshot, which I'll talk more about in the coming slides. All right, for the both connections that were set up in Airbyte, the cron job was to run at daily at 4 p.m. Eastern, with the following settings I used. As you can see, only one of the two connections is shown below, so the other one is not here, obviously. Just to show you in the screenshot all the settings I've chosen. As a cron job, I used the destination namespace where this data is to be loaded. And for just another note on this part is that I've opted out for, let's say, if there was a schema change in the data source in Google Ads, then I've opted in rather for the manual approval that would require this pipeline to be up and running more frequently. Just because I maintain this pipeline on a daily basis, I'll be able to sort of manually approve this on a timely basis. Moving on to the next this slide. I just wanted to show you and to start talk about the sample output of the raw extraction in Airbyte, how those jobs sort of look like in the UI. Every one will show either sync succeeded or failed. So far, all of them has passed, as shown in the screenshot. This is only showing one of the connections, by the way. As you can see, they're all to be run at 4 p.m., which they do. And they even tell you sort of the duration, so it's 3 minutes 13 seconds at the last run. All right, now to talk about sort of the issues I encountered or the errors I ran into in this part of the project. So upon the dbt models running, there was an issue with one of the tables, or rather streams, which they call in Airbyte, called ad group ad legacy, that was causing the pipeline to fail. You can see more details at the bottom, but I'll talk more about them right now. Here, the encounter the errors, I've taken a screenshot and put it here as well. This is sort of the error which just keep coming up. I think this is due to the error in the Airbyte version I was using. To solve this sort of error at hand, I opted into sort of to create two separate connections. One to isolate this table, which was keep giving us the error, and the second was to include all the tables except for this table. So as you can see here, there are two connections created. One is only one which keeps only the ad group ad legacy, and the other keeps all the other tables required except for the ad group ad legacy, as shown below. All right, moving on to the next section and to talk more about this DBT tool for data transformation. The following tasks were sort of carried out on the Google Ads data. Just to sort of give us an overview of this section and the data transformations carried out in this project. We opted in for rather ELT process using a multi-layered data architecture called staging, intermediate, and mart. Staging layer, just to sort of give a background, is it's a raw, minimally transformed data from source systems. Intermediate layers where the transformations are taking place, all the heavy transformations are taking place, are ready for analytical use. And the mart layer is the final output of the model. Rather, for us, it's going to be the two views of two big tables, keyword and ad view, as was shown earlier in the slides. All right, moving on to this next slide. One of the resources used for this project was the Google Ads API documentation. They enabled us to look at exactly what tables we wanted to use, what dimensions, what metrics, what sort of SQL code or code rather we needed sort of to use for our project. The screenshot on the right shows sort of what exactly the metrics will be called in the API, what sort of how will they show up as, and so we incorporate those in our pipeline. The link is also present in the slide. All right, moving on to a bit more detail. So I want to talk more about the staging layer, intermediate layer, starting with the staging layer. These were all the following tables that were used: ad group, ad legacy, ad group, ad group, campaign, keyword view, and ad group criterion. All of these tables were used to produce the final output. There's a Venn diagram at the bottom to talk more about it. For the ad view table, we only had to use ad group, ad legacy, ad group, ad, and ad group, and ad campaign. So for keyword view, we ended up using ad group table, campaign table, keyword view table, and lastly, ad group criterion table. Next, moving on to the intermediate layer. Again, as I mentioned, this is where all the transformations happen, all sort of the major transformations take place here. One thing I wanted to bring to your attention was the ad view table, which is the final output, one of the final outputs, required a lot of transformations because of the way the data was sort of ingested. Just talk more about it. So for ad view, specifically ad names were extracted, were needed to be extracted from a rather early messy JSON list of JSONs found in this dimension called ad group ad responsive search headlines. One of the key dimensions required were the ad names for this view to be created. So for this cleanup to be done, this transformation to be done, I'll talk to you more about it in the next slide, which is right now. As shown in the previous slide, we need to extract the ad names so that we're able to report on the ad level information for the ad view. So the transformations carried out in the step were: first, take the list of JSON and extract the names in a list called and store it in the dimension called aggregated text, which you can see at the bottom in the screenshot below. Then the next step would be to take the many names of the ads in the aggregated text and break it down into separate dimensions. So for example, ad group ad name 1 would have one ad from the aggregated text column. Same thing would be done for ad name 2, which is going to take the next name available in the list in the aggregated text dimension, and so on and so forth. This is how we were able to take a very messy JSON list of JSONs, and the final outcome or final dimensions we were looking for can be found in ad group ad name 1, ad group ad name 2, which is the name of the ads. Now to talk about the mart layer. Mart layer is the final business facing data sort of view we're looking for on this project. To resurface the three sub layers of the smart layer is ad view, which is the big table depicting the ad view in Google Ads website. Second is the keyword view, which is the big table depicting the keyword view in the Google Ads website. And lastly, incremental model. I use incremental model for ad group ad legacy table, which I've shown earlier. and I'll talk more about why the use of incremental models and why I'm using this particular table for incremental model. Just to mention here, one of the issues, or rather I ran into, was for a keyword view big table. Due to the size of the model and the size of the EC2 instance, the model had to be broken down into three models. As you can see, the reason is because we were running out of space. We were running out of memory, as you can see in the screenshot below. I'll tell you more about the fix in the next slide. The fix rather was to break the big model into three separate models. As you can see in the screenshot below, there was step one, step two, and then the final output, which is called keyword campaign ad group UI, as shown below. Move to the next slide to talk more about the incremental model. As I mentioned earlier, for performance optimization and cost efficiency purposes, as full rebuilds are obviously expensive and data warehouse charge based on compute usage. Hence, my goal was sort of starting including incremental models as much as possible, where the only new and updated records are processed rather than the whole table being processed again. A few configurations with the reasonings are as follows. Incremental strategy used in this project is called delete and insert instead of the merge due to the lack of the unique key. As the nature of the data doesn't allow us to have a unique key or even a surrogate key, because there were so many dimensions which sort of goes against the nature of this incremental strategy, which is merge. So I opted into use a delete and insert. Next, incremental model has a look back window, which I created is of 14 days. So the data that is added is only from the last 14 days rather than the start of the data pull. Third feature I included were batch IDs. So every time there was a new sort of incremental model run, those will be separate in a separate batch ID. So if I were to go and debug any issues with the run, I'm able to sort of isolate it based on batch IDs for every batch run. As you can see in the screenshot, batch ID, an example of that is shown here. For every run, there will be a new batch ID created for incremental models. All right, to talk about the lineage graph or the overall picture of the DBT transformations, here is an overall overview of staging tables, intermediate tables, mart tables, and our source tables. I'll talk in more details about it in the coming slides, as there's a lot going on here. But this is more detailed breakdown in the future on the coming slides. So as I mentioned earlier, this is a sort of a more digestible format where we can see what are the key source tables. So starting off with add view. Add view, we can get the data from source, where we have staging tables, and then we have intermediate tables feeding into our final output, which is the mart layer called campaign ad group add big table. I've included the incremental model here, as this incremental model is under test, and I'm still evaluating and seeing the accuracy of the incremental use. But I did include the incremental model just as shown here. The only change you will see here is instead of using staging table for add group add legacy, I'm using incremental table for add group add legacy, which is powering our big table, as shown at the bottom screenshot. All right, moving on to the keyword view. So in this view, we have the following staging tables, and we have the intermediate tables as well. Then the final view is the keyword campaign ad group UI, which is the keyword view big table, which is going to be shown in the Looker Studio. And these are all the sources and the models for this, which is powering this view. All right, moving on to the next section. All right, to talk about this next section, which is about data storage, the tool I use is Postgres, as mentioned earlier. And in this section, I'll talk in more detail about this setup, the problems encountered, and so on and so forth. All right, overview for this section is the following tasks were carried out: set up the data storage in Postgres for source and transform data, and the schemas we're going to be using. The following schemas and their purpose is shown below. So firstly, Airbyte creates its own schema called Airbyte underscore internal, which is automatically created. The ones which I created is Next one is Google Ads Acrobat Legacy, which I mentioned earlier, is only going to have the table called Acrobat Legacy, which is ingested by Airbyte. The third schema is going to be Google Ads without Acrobat Legacy, which is going to which is going to include all the tables except for the Acrobat Legacy ingested by Airbyte. The reason behind this is already mentioned in the previous slide 22 to be specific. And the fourth schema, which is where all the output of DBT models are stored in. The next slide, I'll discuss more about this specific schema called gads_dev, where all the DBT models runs are stored, or rather outputs are stored. All right. As mentioned earlier, to talk more in depth about the gads_dev schema that is populated by DBT models. To reiterate, we used the staging intermediate mark infrastructure as part of this ELT process. So extract, load, and transform. Okay, so as per the dbt underscore project or YAML configs configurations, staging all the staging models in this layer is to be outputted as a view in Postgres. All the intermediate, so talk about the intermediate model, all these intermediate models are to be outputted as a view as well. And lastly, all the MART models are to be outputted as a table as per these uh, configurations, as you can see in the screenshot on the right side. Next, to sort of talk about more detail as to some exceptions to this configuration. So as shown on the far right, a few tables which would not fall under this would be the incremental model table called incr underscore gads underscore ad group ad legacy, and stg underscore Google Ads underscore ad group ad legacy. This is because due to the Postgres limitation, rather, for incremental models, the base table, which is created in incremental, has to be a table and not a view. Henceforth, I had to create both, as you can see, staging table as a table, and incremental is always going to be a table. So these were the only two exceptions and the reason behind it. Next, to talk about an error I was encountering, and which I also talked about in slide 24, which had to do with sort of the memory running out. Another fix, or rather a permanent fix, which I found for this was to just increase the storage. As you can see on the bottom right, the Docker container size of the shared memory directory was increased to 1 GB, as you can see in the Docker Compose file at the bottom right. Specifically on line 5, you'll see this change being added. This solved the problem, has been running very smoothly and with no errors so far. All right, to talk about the seventh section, which is visualization, the tool I use is Looker Studio. And the overall overview for this section is to mainly talk about the tasks which are carried out to connect ads and keyword data marts created in Postgres with Looker Studio to sort of show our final output of this pipeline. Looker Studio was chosen as a data visualization tool for its ease of use and streamlined connectivity with Postgres. This setup literally took me less than a minute or two, I would say, to connect and get it up and running. I've laid out the sort of the setup process I use. So we will need the host name IP as shown in the screenshot, a port number, database name, username, password, and then next slide I'll talk about more about this setup. To continue with the process of connecting ads and keyword data marts creating Postgres with Looker Studio, you would have to sort of after you input all the things I talked about in the previous slide, now you would have to, since Looker Studio goes directly to the public schema, we would have to add this code which I've mentioned here for it to connect to the right schema in the table. So for add view, you can see in the slide, the code is present. If you put the code in and configure this accordingly, you should be able to connect to the Postgres schema as shown at the bottom right. All right, you can follow this if you want to replicate this. Both are done for add view and keyword view, as you can see here. All right. Next, this is where we'll be able to tell if our pipeline is working and is accurate. Here in the next couple of slides, first I'll talk about the add view. I'll be comparing the Looker Studio tables, which is our final output of our pipeline, and comparing this with the Google Ads user interface website. So starting off with the first one is just some notes before I go show you the data. The first thing is for Looker Studio, as you can see in the slide, the view is of the Looker Studio ad view. And just a note to make here is due to the conversion window and the campaign launches timeline, ad data in Looker Studio will only match Google Ads user data, user interface data for the date range of greater than or equals to last 41 days. And data any sooner than that would not have had enough time to sort of process, and so the campaigns will be ended in time, so it wouldn't be matching one to one. Anything after greater than or equals to last 41 days, the data will be as accurate as it gets. As you can see here, this is the final output of our pipeline for one of the views called ad view. Here you can see the same dimensions mentioned. The ad names are here, the campaign names are here, ad group names are here, ad groups ad status is here, and costs and clicks as metrics are here. The next slide, I'll show you this exact view, but in the Google Ads user interface, which will be matching 100%, hopefully. Here you go. This is the exact same view we shown in Looker Studio, but this is from the Google Ads. Just to show you it's working, it's accurate. You can, for example, take row number one, first row. You'll see the cost being 228.61, and you'll see the same thing here, 2228. With the clicks being 75 as well. So with the name, how to become a data engineer, and you can see this in the first line as well as ad name one. So it's working. Ad view is all good, up and running. Next to talk about the same process but for keyword view. Another note here would be the data will be accurate in matching the Google Ads UI if the date range is of greater than or equals to of last 30 days. As you can see here, November 1st, today is December 1st at the time of recording. November 1st was the date, was 30 days before, and this is the data it shows. This is the data it shows. For the keyword view, we have the keyword, the date, the match type, the campaign name, the ad group name, the ad group trading status, which is the status. Now to compare this Looker Studio view to the Google Ads view, in this slide, you'll see it matches 100%. Here you can see the keyword, for example, data engineering courses is also found here, data engineering courses. The cost is 104. Cost here is also 104.44. And clicks are 25. And clicks are 25 here. So it's matching. And the date is November 1st. And you can see November 1st here as well. So good thing. All the data is matching, is accurate. The pipeline is a success. All right. To talk about the future iteration or improvements I would like to make to this project, this section will be covering that. To start off, to discuss improvements, new features that are to be added in the future iterations of this pipeline. Firstly, starting off with incremental loading, as I think I mentioned earlier as well in the other sections. Incremental loading is very important for efficiency, saving cost, especially with large data sets. Incremental models are to load only the new or changed data. As I've been testing the incremental model with one of the tables, the goal is to introduce this to other tables as well, and to maintain data quality as well. Next improvement I would like to make is the incorporation of in the aspect of orchestration. I would like to incorporate orchestration tools such as Airflow, Perfect, or even migrating to DBT Cloud to sort of use the orchestration features in place of cron tab, which I already have in place, to sort of deploy DBT models and take it to the next level. The third and one thing I'm looking forward to very much is the integration of CI/CD into this pipeline, which brings obviously many benefits, few of which are automation of the building, testing, deployment, collaboration with other team members for this code, faster, more frequent deployment as well, and which enhance will obviously increase the quality, so the errors are being caught early on, all through sort of automated testing. And the tool I'm looking forward to using is GitHub Actions for this, or perhaps even when I move to when it possibly if I choose GPT Cloud, that could also be used for CI/CD as well. In the next slide, I'll talk a bit more about the improvements and features that I'm looking forward to incorporating. One of which is data validation, so to maintain the high data quality in ingestion and transformation. I would be incorporating more of DBT test, built-in test, not null, unique, accepted values, and so on and so forth. Another tool I'm looking forward to using is, or rather, open source data validation tool is Great Expectations. Sort of even increase the data quality of the data. And second last would be the including error handling and logging. To some extent, I already have this in place, but I would like to also include alerts, logging for errors, which sort of get alerts like email, Slack message, where if something fails, I'm able to jump onto it really quickly. Airbyte and DBT both have this functionality as well. Um, um, for DBT specifically, logging features such as like on, run, and hooks can be used. I'm going to be exploring more options as well. This is one of the key aspects I do want to include and improve on. Lastly, the upgrade. I would like to upgrade and migrate this project to GCP to sort of see and compare features, cost, incorporating BigQuery as well instead of Postgres. Also, potentially looking into DuckDB for sort of seeing if I can reduce costs and do some debugging in that before I migrate to BigQuery as well. So that will wrap this section up. Thank you for viewing this video. If you have any questions, concerns, you can reach out on my email. LinkedIn website is attached. Thank you all for listening. Bye now.